Newton's second law is the relationship between three physical variables, one of which is mass. We've got myself, the bike, and the child trailer. That represents our mass, our inertia. By pedaling forward, I'm engaging a force, and the result of that force is the whole system accelerating. What we're going to focus on in the classroom is the relationship between force, mass, and acceleration. What I'd like to do right now is have you look at the rate of acceleration of me pulling the child trailer as compared to me going forward without the child trailer. Now watch the rate of acceleration now that I've unhooked my trailer. By doing so, I've decreased my inertia, decreased my mass. Isaac Newton's first law of motion is merely a restatement or a formalization of Galileo's observations, and it is known as the law of inertia. So this first law has a nickname, if you will, and it's called the law of inertia. Now the law of inertia states that an object in motion will stay in motion at a constant speed in a straight line, and an object at rest will stay at rest unless acted upon by an external force. Now that is the formal definition summarizing all of Galileo's conclusions. So the law of inertia states that an object at rest tends to stay at rest, and an object in motion tends to stay in motion. Keep going here. What kind of motion? He goes on to formally describe what kind of motion. And by motion, he means at a constant speed in a straight line. And from our previous definitions, we can refer to constant speed in a straight line as constant velocity. So an object in motion tends to stay in motion at constant speed in a straight line unless acted upon by an external force. Now, this is the formal definition of the first law, whose nickname, if you will, is called the law of inertia. And it is with this detail that I really communicate strongly to my students that I expect them to know. So when I say, what's Newton's first law? It's not just inertia. Give me more. What does that mean? Because Galileo spent a good chunk of time gathering observations on objects in motion in direct challenge to Aristotelian belief. And Newton is summarizing those thoughts. Now, this concept of inertia has a few meanings nonetheless. Inertia has a root that means laziness. So this idea, this word, inertia, has a couple different meanings to it. One is laziness. And this laziness is really reflected more and more accurately defined, even by Galileo, as being a tendency to resist a change in motion. A tendency to resist change. Tendency to resist change. Now, what we're really talking about, the change of what? We're talking about a change in motion. Well, let's look a little bit more closely at this laziness factor, this laziness thing, this tendency. This right here is a huge word in that definition. Let's look a little bit more closely. Have Gail already out for us. I also want to look at a basketball, tennis ball and a golf ball, a ping pong ball, a cannonball, and a baseball under the influence of a bat. All right, let me move some things here. Okay. Okay. If we take these balls and we line them up here, we'll line all the smaller ones up first and then we'll do the bigger ones. So we have a cannonball, a baseball, a tennis ball, a golf ball, and a ping pong ball. Now, if we were to take a bat and if I try to strike or influence these objects' motion, right now they are at rest. They want to remain at rest. Their tendency is to remain at rest. But I'm going to try to challenge that state of motion by whacking them with this bat. Now, for every one of these objects, I'm going to try to whack them with the same amount of effort. And I want you to really get an idea of how they react to this effort. So, if I just simply, okay, nice even effort here on each of them. So, if I whack the ping pong ball, it takes off pretty quickly too. If I whack the golf ball, yep, there it goes. And you observed its motion relative to the ping pong ball. And then we have the tennis ball, the baseball, the cannonball. Now we bring up the basketball and Gail. Don't worry, she's used to this. All right. Well, we see that each one of these balls reacts to the bat differently. Why? We can see that each one of these objects has a tendency to resist being changed. But what is that tendency a reflection of? Where does it get the tendency? We spoke that Galileo defined inertia as every object has this tendency, this intrinsic desire to resist being changed or changing its motion. But where does it come from? Well, we can bring all the balls in comparison to one another and show that the difference between them lies in their mass. And so, inertia is also a reflection of an object's mass. It is in mass that the object has its natural tendency to resist being changed. Now, we saw with Gail that she had a tremendous amount of mass. And with knocked with the bat, that mass translates into a huge effort to resist being whacked. Now, the ping pong ball didn't have that effort. It had a small amount of mass in comparison to Gail, and therefore had a smaller tendency to resist the effort applied to it by the bat. And so, its resulting motion was greatly different than Gail's. So, we see that inertia has a complete formal definition around the concept of this tendency to resist change. And this tendency to resist change that we call inertia is physically measured by the object's mass.